All right, let's look at an application of a quadratic equation. This function, f of x equals negative 0.002x squared plus 0.77x, models the path of a baseball, where f of x gives the height of the ball and x gives the distance from where the ball is hit in feet. So 3 questions here. Part A, how far does the ball travel before hitting the ground? B, how high does the ball go? And then C, what is a reasonable domain and range? All right, let's think about this for a second. Based on my equation here, I know I have a parabola because I have x squared. I know my parabola is upside down because this a value is negative. So my parabola, I don't really know where this parabola is, but I know it looks something like this. Okay? If x is the distance the ball traveled, and f of x is my height, let's think for a second. For part A, how far does the ball travel before hitting the ground? What about this graph am I trying to find? Well, when the ball hits the ground, my height is 0. So I want to find my x-intercepts. I want to find when my function equals 0. So I really need to solve this quadratic equation. Negative 0.002x squared plus 0.77x equals 0. And I don't know about you, but I don't exactly want to try factoring this. Maybe it's not as painful as it looks, but I don't really want to try this. What we could do, though, is to graph. Let's go on our calculators. Go to y equals negative 0.002x squared plus 0.77x. And let's see what we're dealing with here. All right. Well, oops. We're going to have to adjust our window a little bit. First of all, if I am talking about x values as my distance the ball traveled, I'm not going to go a negative distance. So x min, let's make this 0. X max, well, I'm assuming this ball probably goes a decent length, so let's maybe change this x max to, I don't know, 200 feet. That sounds reasonable for a baseball. I have no idea what my y values are going to be, but we can zoom fit to help us find them. All right, and it looks like we're pretty darn close to our vertex here. We might need to go just a little bit farther. Okay. But it's really not the vertex that we're trying to find, is it? It's our x-intercept. Let's make this x max 500. Ah, there we go. Okay, so x min is 0, x max is 500. Okay. Let's find my x-intercepts now. To find them, we go to second calc and 0. And I'm going to scroll a little ways. And actually, since my cursor is over here, I'm going to start with this x-intercept. Okay, my x-intercept here. I'm on the left side here. Left bound, enter. Right bound, I need to go a little bit farther. So you can't actually see my cursor right now. But here's about where my x-intercept is. I'm going to go to the right a little bit farther. Just go to the right a couple more times. Hit enter. And then we can come back in. All right, so we have an x-intercept at x equals 385. So that means the ball went 385 feet before hitting the ground. Well, we should probably double check too what this x-intercept is just to make sure our situation makes sense. Second calc 0, we scroll. Okay, left bound, go to the left a little bit. Right bound, and enter. All right, so 0. Okay, 0 feet, the ball probably didn't really go 0 feet. Okay, that's just where the ball started. So at 385 feet, our ball went before hitting the ground. Part B, how high does the ball go? Actually, before we go on to that, I'm going to make a little note here. That we need to define our x-intercepts. Okay, how high does the ball go? Well, the highest the ball goes, that sounds like a vertex to me. Let's find our vertex. And if you wanted to, this equation is in standard form. You could definitely use negative b over 2a to find that vertex, or we already have the graph here. We can use our graph as well. So to find our vertex, is this a maximum or a minimum? Well, this is the highest point, so this is a maximum. We go to second calc, maximum. And we still have to use that left bound, right bound process, but now we're trying to find this vertex. So left bound's over here, right bound, and guess somewhere in between. All right, so our maximum, well, we don't really care about our x value here. We care about how high did the ball go. So the ball went 74.1 feet. And then C, what is a reasonable domain and range? So keep in mind that domain is talking about our x values, and range is talking about our y values. In this situation, x is representing the distance our ball traveled. Well, we can't go a negative distance. So x has to be more than 0. And let's see, our situation, the farthest distance that makes sense was right here, 385 feet. Because once we get past 385 feet, our ball goes underground. That doesn't make sense. So x has to be between 0 and 385 for our domain. As far as our range goes, well, we can't really have a negative height. Range is talking about y values. The highest the ball went was 74.1 feet. So y has to be between 0 and 74.1.